Okay, let's get started with this session. So today we are talking about upgrading a canister and memory. It's a really important topic because you will very often be confronted to upgrading your canister. You will want to add more functions, add more features, fix a bug, and so on. But you don't want to lose your data. You don't want to lose all your users. You don't want to lose all your previous variables and so on. So how do you upgrade a canister without losing your data? This is essentially what we will try to solve today. And before we dive into the code, I want to explain very quickly the different types of memory in a canister, because there are actually two types of memory, and it's really important to understand that when you want to dive a little bit more. So there are two memories. There is the stable memory and the heap memory. And so the heap memory is currently 4 gigabytes. It's the memory, I would say, by default. So when you declare a variable like let's name, this is going to be stored in the heap. And every execution, every function execution, every code that runs by default in the heap. The heap is the fastest available memory. And it's also the one that is unfortunately wiped out during upgrades. So when there is an upgrade, the heap is cleaned and you lose all data that is stored in the heap. The second memory is the stable memory, which is currently up to 300 gigabytes. It's actually not, 300 gigabytes, sorry. It's not up to date here, so I should modify that. It has been constantly increasing. The stable memory, as the name suggests, is stable, so it survives upgrades. And if you have anything that is stored in the stable memory, you can, after the upgrade of the canister, you can reaccess these variables and this memory. The downside of the stable memory is that the stable memory is slightly slower than the heap memory. It's a factor of 2 or 3 times slower. So in terms of access, write and read, it's going to be a little bit slower. The question I always receive is which memory should I use, when, for which purpose? And it depends. There is not one answer. It depends on the requirements of your application, the number of time you plan to upgrade, also the performances you're looking for, and all sorts of concerns. Also, there is something coming up which I shouldn't be talking about, but I will, because it's later in the future. So we are in 2024. I think at the end of the year, like within the next year, this year, the Motoko team that is working on the Motoko language, they will modify the runtime of the language and the compiler so that these distinctions between those two memories disappear, and everything that you do is by default in stable, so it will be safe during upgrades. So the thing is that we are really early right now, and this Motoko language is evolving. So as I'm doing those bootcamp and I'm teaching you this, it's possible that in a few months, maybe in 1 year, this will be abstracted away because the Motoko language is evolving, getting better and getting easier for developer. And so probably those concerns of memory are going to disappear, or at least be abstracted away. So if you learn that, it's always going to be valid, but it's just that one day it won't be among the necessary knowledge, but at least you will know how it works behind the hood. So that's also great for you. And also if you want to build right now, this is the valid concerns, because all projects on the IC have this concern. Now let's go back to the code, and I will make a demonstration of what I'm talking about exactly. So let's define a counter. So this is a variable. It's a natural number initialized to 0. We have one function to increment the counter, one query function to get the counter, and a function to reset the counter. So let's deploy this canister, and we will deploy it in the playground. The name of this canister is upgrade. Okay, now let's take a look at our code. So my counter is initialized to 0. Now, if I increment it and I query again, it's going to be 1. And so if I upgrade my canister, so maybe let's say I remove this method. So comment that out and I'm saying, okay, I don't need this method anymore. Now I redeploy. By default, when you redeploy, you are upgrading your canister. So you are changing the WebAssembly module that is inside, and this is called an upgrade. This is another concern when you upgrade, which I will talk in the second part of this lecture. So not right now, but later we will see that when you upgrade, there is also something called interface compatibility. So you are changing the interface of your canister, and there are some authorized operation that you can do and non-authorized operation. This interface compatibility is not really for you, like it's not really for the problems that you will cause to your canister, but more about if other canisters are built on top of you, so they are using your interface to do inter-canister call, and you change your interface, you can cause issues to other canisters. So this is, in a second part, we will talk about that. But right now we are focusing on the memory of our own canister. So let's just proceed with that. Okay, and now I guess you probably already know what's going to be the value of the counter. If you follow the lecture, this variable was in the heap memory. So if we have upgraded, it should have been reset, and now the counter is 0, even though it was 1 previously. It's 0 because when the code is redeployed, then let's say this line is re-executed in the sense that the variable is reinitialized to its initial value. Now let's make a test and let's add this stable keyword before the variable and see what it does. I noticed the playground was running very slowly a few hours ago. Yeah, for me it seems to work, but sometimes, yeah, when it can be slow sometimes. So my counter now is 0 again. If I increment it, it's gonna be 1. And now if I do another modification, so I'm not very creative this morning, but I'll just put back the function that I had removed. I'm doing this because if you don't do any modification, you just redeploy, basically the tool DFX knows by default that it's the same code and it's not going to change the module. So you need to make like a slight modification. So now I have redeployed and it should be 1 because my counter is stable. And you can see that now it's 1, even though I have upgraded my canister. I just upgraded my canister. So it seems super easy. Actually, if you just want to make a variable stable, you just have to add the stable keyword and then everything is good. Your variable is saved in during upgrades and you don't have to worry about anything. Well, unfortunately, it's not so easy. It's really easy for some types. So for example, the natural numbers, the text, they can be declared stable. But if I declare a hash map, and I think I have one here, this one. So let's remove that. Let's say I have a type user. So this is my type user. I have a name, age, and email in the fields. And then I create a hash map that stores users, and the key for this hash map is the principal of those users. Let's say I want to make this variable stable. Variable users is declared stable, but as non-stable type. So this is something that we now are familiar with Motoko. There are some types, and some of them are nice, some of them are not so nice. We have the types that we can share, we have the type that we can declare stable, and we have the types that we cannot share and we cannot declare stable. So it seems that the hash map, being a class, cannot be declared stable. In general, any type that is a class, so the buffer would be also something that is a class, cannot be declared stable. And any object that has a non-stable field cannot be declared stable. So what I mean by that is that if you have an object and you have only one of the field that is not stable, you cannot declare it as stable. So how do you do that? How do you deal with, stable structures when the structure that you want to use is not stable? So there are two solutions. There is an old solution, which I will show you, but you should try to move away from it and not use it. And there is a new solution. The first solution would be to use what's called as a pre-upgrade and post-upgrade methods. So you create a hash map, and then you create a stable data structures that will store the content of the hash map during the upgrade. You can call that however you want. In my case, I have called it user entries because it's going to store the entries. So I'm going to loop over my hash map. And every time I have a principal and a user, I will store that in the array. So I will essentially empty my hash map before the upgrade, store it in the array. The array can be declared stable because the array is a stable type. Then I upgrade my canister, and when the upgrade is done, I put back all the content of the array inside the hash map. So this works. Actually, we can try it out now. For example, if I I will need to add two functions. So I will need to talk about two functions. I will need to talk about system function pre-upgrade and system func post-upgrade. Those are two special functions. As you can see, they are like called as system functionality because those functions are run before an upgrade and, well, this one before and this one after the upgrade. So here in the pre-upgrade, what I'm going to do is that I will put the content of the hash map inside the array. So user entries will be assigned to iter.toArray user.entries, like this. And in the post upgrade, what I will do is that for principal user in user entries dot values. So this is also a good way for me to show you how to loop over an array. So you have an array here, you can loop over the array like this. It's users.entries. Then I will do users.put and principal user. So I'm looping over my array, and for every tuple, I'm adding the tuple inside the hash map. Now let's try to deploy that. So let's take a look. We have also I forgot to say we have the add user method and the get users method to look inside our hash map. Okay, so I'm adding one user. Then, okay, I can see the user. And now if I upgrade, let's say, again, this method, oops. Okay. Now I have upgraded and it should be back inside my hash map. So yeah, I can still see my user. Why is this a bad way to do it? So it was actually originally the way we would do it when the IC was very new. This is something that I've done a lot in the past, but now it's recommended to move away from this pattern because we have now more and more stable data structures. So a stable data structure is a data structure that we can store, that we can declare as stable, just like we've done with the counter and just like we've done with the array. But the stable data structures that we have now are much more, I would say, complex. So in the beginning, we had only like really basic one. So for example, a Nash map was not stable, but now with the help of the community, we have a lot of new stable structures that are really good. And actually, now it's time for me to introduce the MOPS package manager. So MOPS is a package manager from Motoko that is completely on-chain. So it's built on DIC, and you have access to Motoko packages that can be created by community members, and you can download them and you can use them in your own code. It's really easy to like use MOPS. You just need to like read the start documentation and then how to import packages. And most of the, I would say the most used packages are the one that provide stable data structures. So one that is really used and really interesting is the map. Map is a stable hash map. So essentially, it's a modification from the traditional hash map to make it stable. And there are ways to do that. I won't go into details, but there are ways to do that to make it stable. And it's very useful to use it if you are looking to make stable data structures. So there is this possibility number 2, which I will show you in a few minutes. But also, we try to move away from this pattern because it's simply not good, because there are many issues that can arise. One issue that can arise is that when you move your data, so you move from the hash map to the array, and then you move back, something wrong can happen. And if something wrong happens, so if it contains like corrupted data or there is an index out of range and your canister trap, so trapping is a form of error that your canister cannot recover from. One easy way to trap is to use an assertion and then assert false. Assertion is going to test the content inside the parenthesis. And if the assertion is true, it's going to pass it. If it's false, it's going to trap. So here, of course, false is false. So it's going to trap. And of course, no one would do that. Like you wouldn't on purpose use this inside your pre-upgrade. But let's say you have something wrong, there is something wrong in your code and your code trap, then you will see that this is a huge problem, because if you trap in your pre-upgrade, you will never be able to recover your canister. So your canister will be, I would say, stuck and trap forever. Okay, so that like right now, we don't see any error message because the pre-upgrade, so we have upgraded our canister and there was no pre-upgrade method yet. I mean, there was not this assertion false. So we have run one upgrade, and now if we run other upgrades, we have this pre-upgrade that is the new one. So now if we run a new upgrade, we should see an issue. And I can, well, actually, did it really upgrade my canister? Yeah, I think it did. Okay, let's see what's happening. We should see an issue. So this is what I was expecting. You can see the replica returned a replica error, reject code, reject message, canister, and then you have the canister ID. Trapped explicitly, assertion failed at main.motoko, line 42.9, character 9, 42, character 23. Error code none. So it doesn't seem like a really, a really good error. This is not something you want to see. So line 42, we can take a look. This is line 42, it's here. And so this is the problem. But now, how do I solve that? I can't, because if I want to upgrade my canister to solve this problem, I cannot do it because it's always going to run this and it's always going to trap and it's never going to recover from it. So yeah, something to avoid. It's really not good if you are in this situation. There is absolutely nothing that you can do. So it's really not something that you want to experiment. If you had a trap in the post upgrade, it would be a little less problematic because you can, well, it would be less problematic because um, you can still upgrade and you can still have the new code that executes. So it's less problematic. Okay, so how do I use the possibility number 2? How do I use the stable structure? Let's take a look at mops. So mops. So assuming that you have Node.js install version 18 or 18 or more, and you have dfx install at least dfx 0.10. So we are at 0.16, so it should be good now. You can install the mops CLI globally by running this command. So by default, it's something that you should already have on your coding environments on the Gitpod, the workspace. And also I already have installed it on my machine, so I'm not going to run that again. What I'm going to run is, let's remove that, mops init. So mops init is a command to initialize mops files in your project if you want to use mops, the package manager. You can select if you want to use mops to use packages or to create packages. So today we want to use packages. You can set up a GitHub workflow. I'm not interested in that. And then it's going to add a file, mops.toml, where you will list all the dependencies that you want to use. Actually, it's going to do it for you by default. By default, when you do mops init, it will automatically load one package, which is the base library. Yeah, the base library, which is the base package, and it's going to download the latest version of the base library. Then you need to modify your dfx.json. Just need to add mops sources. So I already have done it, but essentially you need to have this default build pack tool, and then mops sources will give you the right command for mops. And then you can add packages as you want with mops add and the name of the package. So let's say I want to add the map package. I'll just run mops add map. And now if I take a look here, map has been installed. And now I can use this map package directly inside my code by running this. So import map, Motoko map /map. And I can also import some specific functions from the map library, which I'm going to import this one. I'll explain what it is. And then, well, I guess it depends on the package, but there is a little explanation. There is a documentation on how to use each package. So in my case, to define a map, it's gonna be map.new, the key, the values, and that's it. So to create stable users, I'm going to define that stable let user stable is equal map.new. The keys are going to be principal and the values are going to be user here, this type. And then I can see how to add elements inside the buffer, inside the map, and how to get element inside the map. So to add a user, I will simply run map.set. Usually stable data structures, the downside is that they have more parameters in the arguments that's compared to like HashMap. For example, there will be more functional methods than classes. So classes would have more methods where you can do .add, .put, like the buffer and the HashMap we've seen. The stable data structures will usually have more functional types of methods. So you would need to do map.set, which is a method from the map library. And then inside, you need to specify which hash map you want to do the set on. you need to specify the key, the value, and also you need to specify this utilities functions, which is a principal hash method that you can import from the map library. And that's it. Then you have your map dot set, so it's good. And then you can receive your user's table like this, iter.toArray. So again, you can see that the map from mops is different from the hash map from the base library, because in the base library, we were doing dot values like we've done here, or dot entries or dot values. Here we are doing a functional method. So we are using map dot values, and then we are specifying which hash map we are using this function on. So it's a different type of syntax, I would say. Yeah, so p hash just means principal hash. It's a utility function that you need for this method. Essentially, this method requires you to give the hash function that you would use. You remember that for the users, we would use this, we would specify those functions directly when we instantiate the hash map, and then we wouldn't need to specify those functions later on in any function that we use. For the map, it's the opposite. You actually don't need to specify any function when you initialize it, but you need to give this function every time you use the hash map. And so if we look at what is phash stands for utilities function, and it's actually, it's gonna be here. Yeah, here. So hash principal, and then phash is going to be here. This is of type hash utilities, and it contains the hash method and the equality method. So it's just a tuple that contains the two. And it needs to be provided with each call. And yes, n hash would be natural hash. You have for any type, like Boolean hash, text hash, NAT64, NAT32, and so on. So I'm deploying this new hash map. So this new map, well, of course I need to destroy this canister, and the way that I'm going to do it is that I'm going to run dfx canister install, and mod will be, so I can show you, you have this flag. When you do dfx canister install, you have a flag that is mod, which is where it is. It's here, which enables you to specify the type of deployment that you want to use. You can either install, reinstall, upgrade. In my case, I'm going to reinstall because I need to start from 0 again. So mode reinstall. And this was in the playground, so I need to specify playground. Is it good now? Okay, all good. So this is my hash map, my new map, I would say. And as you can see, it's stable by default. So of course, I still need to declare it as stable. I could use this, even if it's a stable data structure, if I remove the stable, it's not gonna be stable. I still need to specify stable. But as you see here, it doesn't throw any error, whereas here it was throwing some error. And now I can see that I have my age and my user and everything is still there, even though I have just upgraded. So that concludes our first part of this presentation, which was about memory and stable data structures. So to sum it up, anything that is not stable will be deleted during upgrades. Everything that is stable will be saved during upgrades. And you have to be, I would say, look for new data structures and use stable data structures. You can use mobs for that. Now let's take a look at map is better than hash map. Yeah, I would say so. It requires to use external tools, but I would say it's better than hash map, at least at the moment. Eventually, when Motoko at the compiler level will handle that, we will probably go back to using like hash map. But it's like we are in a transitory period, I would say. So right now, I would recommend to use a map. Okay, so the second part, because not everything about upgrades concern the memory, there is another like concern that we have to take into account, which is the interface changes. So a challenge when you are in a distributed environment like GIC is that other canisters might be relying on your canister. So they might be calling your canister in their own code. And if you upgrade your canister, they don't necessarily are notified of that. And they can call like old functions that doesn't exist. Or they can, if you change the types, some of your types, they can call your canister with old types, which will make your canister trap and their canister trap as well. So how do you deal with that and how do we solve this problem? Well, this is mainly why Candid was invented. So Candid, which is this interface description language, Candid is able to essentially, when you upgrade your canister, tell you if there is something wrong, like you are going to break the interface of someone else. So let's make a test. For example, let's say you remove this method. So you just remove a method. Removing a method is considered, I would say, it's considered to be some breaking operation. It's a breaking change because imagine you had a canister that were calling this method, using this method, then it cannot do it anymore. And so when you do that, there is a candid check. So you can see that you have a warning, candid interface compatibility check. You are making a breaking change. Of course, you can still ignore this message. Maybe there is no one relying on your canister and you can still upgrade, but at least you are aware of that. Just to take a little quick look, essentially, you have this upgrade file. So, well, it's a little bit confusing here because my canister is actually named upgrade. And yeah, the canister name is upgrade, but essentially you have this, every time you upgrade, you have the candid interface for the previous canister and the interface for the new canister. And essentially there is this dot old, which is the previous one, and the dot most, which is the previous one. So this is the previous one and this is the new one. And the tool that we're using is going to compare them and see naturally if there is a problem. It will look at the data structures and at the interface. So if you're doing something wrong with your variables and you might lose data, it's going to tell you. And if you might break some canister, it's also going to tell you. There are some changes that we could make, like that would be authorized. For example, let's say you have a function that takes a natural number as an argument, and you decide to change your mind and you change your counter to an int, and then, so this one will cause some issue. This one will cause some issue. Yeah, this one will cause some issue, but this one will be good. So let's say you change your counter to an int instead of a nat, and you change the return type of this function, and you change the argument of this function. Let's see what happens. So this is a correct change to make. It's not going to cause any issue because if you think about it, set counter previously would take a natural number and now it's taking an int number. But every natural number is also an int. So if someone is sending you a natural number and you are expecting an int, you can interpret the natural number as an int and it's completely correct. But on the other side, it doesn't work. So the get counter, as you can see here, it's causing issue because get counter, which returns an int, is not a subtype of the previous one. So essentially it's saying that every int is not necessarily a nat. And so if someone is consuming your interface and expecting a natural number, then they will receive an int and maybe it's like -5 or -10 and they don't know how to handle those cases. So you can see that it's like, it can go like even in the theory of like subtype and supertypes, if you're familiar with those concepts. Like some operations are authorized. You can modify a nat for an int if it's an argument. You can modify an int for a nat if it's a return value. You can also add optional arguments. So let me show you. If you add an optional argument to a function, you are not going to break any canister because it will automatically be replaced by null value. So if no value is specified, it will automatically be null by default. For example, if you do, well, I don't know why you would do that, but let's say you have a other argument here, which would be an optional text. So adding an argument to one of your function is some operation that could be potentially detrimental because if it's not optional, then it would be a problem because the other canister would not know about that and we just send you this with one argument instead of two. But in the case of an optional argument, it's not a problem. As you've seen, I didn't have any error message, any warning, because it will be interpreted as null when the other canister will send you a request. So it's like kind of using the intelligence of the type system to prevent as many errors as possible. So I won't go into every type, like every operation that is authorized, every operation that is not authorized. Usually, to sum it up, you can change, you can take a look at the Candid, I would say, documentation, where all of this is explained in way more detail. And there is even like proof, like mathematical proof of what is authorized, what is not authorized. There is a list here. So you can add new method without breaking existing method. You can return additional value. So if you return more value, old clients will simply ignore those values. You can remove some parameters. The parameters specified by the old clients will be simply ignored. You can add optional types as new parameters. This is what I was saying. When reading messages from old clients who do not pass that argument, a null value is assumed. Existing parameter type may be changed, but only to a super type. So a nat can be changed to int when it's a parameter. And the result type can be changed, but only to a subtype. So int can be changed to a nat. And this is the reference guide for Candid, which is necessary if you want to dive more into this concept. Well, finally, there is a last, I would say, problematic that we can mention here is the fact to change the type of a data type. This is not something that would be done very regularly, but it could happen that you have a variable and you want to change its type, like the type of the variable. Of course, even if you have a stable variable and you change the type, you are going to lose the data inside of it. You can do, for example, let's say you have a user type. This is something that usually happens a lot. You know, when you want to migrate your data, you have an old user like type and you have a new user type with maybe more fields and a different like structure or something. You want to copy the data, you could do that, but you would have to do it manually through a migration pattern. If you do it by default, like by just changing the type in Motoko, you will lose your data. The good thing is that Motoko, the compiler, and the FX will prevent you and warn you before it happens because of the stable type signature, which is the signature that we've seen in this file. So this comes from this file and this one. You can see that you have the stable signature here for all the stable variables. And it's going to be warning you in advance, which is great. So that's I think there was the last section here is the FX warning, which we've seen. So that's about it for the upgrades. I think that's everything that we need to cover. If you have more questions, I'm happy to look in the chat. Otherwise, we can exit this session a little bit earlier. So that gives me time to prepare the next one. There is no database in ICP. You save your data in stable types. So the long-term vision of the IC is that you store your variables directly in the canister in stable like variables and stable data structures. And it automatically scale for you. It automatically like, grow and deal with the storing of it behind the scenes. Of course, we are still a little bit far from that. So there are actually some data structures that are being built. For example, CanDB is a great example. Let's take a look at CanDB. It's a NoSQL database that runs on the IC. And it's essentially scaling across multiple canisters. I'm not sure what is the current status of this project because it was around. The GitHub repository. So I know that now. Yeah, you would probably need to reach out to them if you have more questions. And well, it's not the only one that are working on. It's not the only one that are working on data structures, databases on the IC. There are other like projects. And I think a good way to know about it would be to look at us awesome ICP, the repository. So yeah, okay. So here we have all the currently like storage and databases projects. So CanDB is the first one. I see Oxygraph. I see SQLite, Pseudograph, a GraphQL database. I don't think this project is maintained. Yeah, it's like 3 years ago, so it was a long time ago. And yeah, you can take a look at that. I think it's interesting. By the way, I'm sending this repository. It's a super interesting repository where you have quite a few resources to build on the IC. Yeah, like you have starters, repository, you have more advanced example, agents, you have some dApps, like access to some example of live dApps, monitoring for your canister, and so on. If you add a new field to a custom type, how do you update that field for all existing values? If you add a new field to a custom type, well, if you add a new field, if you add an optional field, it's authorized. I think it's going to be null by default. If you add a field that is non-optional, you would need to do like a migration to your type because it's not gonna be compatible. Yeah, and you would need to like create a migration function where you fill out all the fields that you are adding, and you provide maybe a default value or something, and then you can upgrade like this. So generally, you want to be defining your types before having too much data that is stored. And if you want to migrate, you have to do it carefully. There are some types, there are some cases where you can easily add new types. For example, if you have a variant, and the variant is something that we've seen already a few times, but we haven't dived so much into it. So the variant type is this type, which is where is the, let me see. Okay, here, yes, variance. So the variance is this type where you can specify multiple cases. For example, like a good example would be vehicle, where you have either a car, a moto, or a plane, and then you can define functions where you switch on all the cases and you handle easily different cases. A variance, it's easy to add a new type, like a new variance, without breaking existing like types and data structures. So for example, if you add a new, like boat, for example, you wouldn't break the any variable that is defined as a vehicle. And that's meant to be this way. Okay, so we are 10 minutes before the hour. I will stop this session here, and I see you in the next one in 10 minutes. We have a session about inter-canister calls and errors in Motoko. This one is going to be interesting. We'll essentially call other canisters and see how we can interface with other canisters. This is something that will be needed, especially for your final project.